Hey everyone, and welcome back for another deep dive.
Yes, welcome back.
Today we're going to be looking at something that I think you'll find pretty fascinating.
I think so too.
It's something that we experience literally all the time, constantly,
Yeah,
but we never really think about it.
that's right.
And that is gravity.
Gravity, yeah.
And we've got a really interesting source today from Open Educational Resources.
Okay,
It's called Open Source Physics at Singapore.
nice.
And it's actually geared towards physics students.
Oh, cool.
But don't worry, we're going to bring it down to earth for you.
We will.
And really dissect, what are the key takeaways here?
Absolutely.
And what are the things that are going to make you sound super smart?
Yeah, make you sound super smart at your next,
Cocktail party.
holiday party.
Exactly.
Exactly.
So yeah, I think this source is really neat because it also has some really cool interactive simulations
Yes, it does.
that help you visualize some of these concepts, which
Yeah.
I think is really helpful.
For sure, for sure.
And so the goal today is really to understand how this one force is behind everything.
Everything
From like the tides
for the tides.
to the Earth orbiting the sun,
Wow,
and even how we use gravity to make things like GPS possible.
that's right. It's all connected.
Yeah, it's crazy.
It is.
So I think the best place to start is with something that I think we all experience every day,
Okay.
which is weight.
Weight.
What do you think of when you hear the word weight?
Well, I think of like holding a really heavy object,
Yeah.
like a dumbbell or something like that.
Totally.
You can really feel the weight of that.
Like I was thinking
Yeah.
about when I'm packing for a trip and I'm trying to shove everything into my suitcase.
Yeah.
And like inevitably it ends up being like 52 pounds and I'm like,
Yeah.
oh no, I'm over the limit.
Right. Or those grocery bags when you come back from the store, they're just digging into your hands.
Totally. And it's like, why does this have to be so heavy?
Exactly. And that's gravity right there.
Yeah.
You're feeling the earth pulling down on those objects.
That's so wild.
And you're feeling the resistance to that.
So that feeling of heaviness is literally the Earth's gravity just like pulling down on that thing.
Exactly.
That is wild.
Yeah.
So the heavier something is, the stronger the Earth's gravity is pulling on it.
That's right. It's all about mass.
Yeah.
So the more mass of an object, the stronger its gravitational pull.
Oh, okay.
And the earth is pretty massive. So
Yeah, that makes sense. But it's still so weird to think about.
yeah, it is.
This like invisible force that's just like constantly tugging on us and everything around us.
All the time.
Yeah, all the time.
Yeah.
It's kind of freaky when you think about it.
It is a little bit.
Okay, so what are some other ways that we see gravity's influence, like on a larger scale?
On a larger scale, well, one of the best examples are the ocean tides.
Oh yeah, the tides.
The tides.
Okay, so I've always been curious about this.
Okay.
How can the moon control something as massive as the ocean?
Right.
Like, how does that even work?
So it all comes down to the moon's gravitational pull on the Earth's water.
Okay.
So the moon is actually pulling on the water
Okay.
and causing it to bulge out
Oh, wow.
towards the moon.
So it's not just like the ocean is sloshing around. It's like the moon is literally pulling on it.
It is literally pulling on it.
Wow. Okay. So I have a question about this.
Okay.
So if the sun is so much bigger than the moon,
Yes.
wouldn't its gravity have like a bigger impact?
You would think that.
Yeah.
Right? But distance plays a really big role here.
Okay, so how does distance affect like the strength of gravity?
So there's this principle called the inverse square law.
Okay.
Basically, the further away an object is, the weaker its gravitational force becomes, and it weakens much faster than you might expect.
Really?
Yeah. So think about it like this. If you double the distance between two objects, the gravitational force between them decreases by a factor of 4.
Whoa.
Okay. Yeah. So even though the sun is massive,
Yeah.
its distance from Earth makes its influence on tides weaker than the moon's, which is much closer.
Oh, that's so interesting.
Yeah.
So the moon is closer, so it's got like the upper hand in this little tug of war.
Yeah, exactly. It's like a little tug of war going on.
Okay, so, but I have heard of something called spring tides.
Spring tides.
Oh, those.
So spring tides occur when the sun and the moon actually work together.
They team up
They team up
against the Earth.
to create even more dramatic tides.
Oh, so it's like when the sun and the moon and the Earth are all in a line.
Exactly.
Their powers combined.
Yeah, their powers combined.
Creates like this mega tide.
Mega tide, yeah.
Okay, that's cool.
And astronomers call that alignment syzygy.
Syzygy.
Yeah.
I'll try to use that in a sentence today. I remember seeing on the website they had this cool animation that showed like how these tides change over time,
Yes.
which I thought was really fascinating because it's like you can see how the Earth's rotation and the moon's position kind of cause this regular pattern of like the tides going up and down.
Yes, twice a day. We get those high tides and low tides because of the Earth rotating and the moon's position.
Wow. That is so cool.
It's amazing, right?
Yeah.
This one force creating these complex patterns.
It really is.
Yeah.
But wait, so it's not just tides, right?
No, it's not just tides.
What about like things falling to the ground?
That's gravity, too.
That's gravity too. So like
Right.
if I drop my pen right now, gravity's going to pull it down.
It's going to go down.
Okay.
Yep.
So are we saying that the same force that causes like these little everyday things
Yes,
is also responsible for like the Earth orbiting the sun?
that is exactly what we're saying.
Whoa, that seems like a big jump.
It might seem like a big jump, but gravity operates on a universal scale.
Okay.
So the Earth is constantly being pulled toward the sun.
Okay.
Just like that pen is pulled towards the Earth.
Okay.
Yeah.
So, but the Earth isn't just like plummeting into the sun. So what's going on there?
It's because the Earth is also moving forward really fast.
Okay.
So instead of crashing into the sun, it ends up perpetually falling around it.
Wait, are you saying that the Earth is constantly falling towards the sun,
Yes,
but its speed keeps it from actually hitting it?
exactly.
That's like why?
It's like if you throw a ball horizontally,
Okay.
it'll curve downwards as it travels.
Because of gravity.
Because of gravity.
But if you throw it fast enough, it'll travel a longer distance before it hits the ground, right?
Right now, imagine throwing that ball so fast that the curve of its path actually matches the curvature of the Earth.
Oh my gosh.
That's essentially what's happening with the Earth and the sun.
Whoa, my mind is blown.
It's pretty amazing.
That is incredible.
Yeah.
So this one force
Or
is responsible for like
everything
everything
from a falling pen.
to the Earth orbiting the sun.
That's right.
Okay, I bet there's even more to this story.
There is.
Tell me more.
Okay. Are you ready to talk about satellites? Okay.
This is where it gets really exciting for me.
I know, me too.
Satellites.
Satellites.
These are the things that are like zipping around above us all the time.
They are.
How do they fit into all of this?
So to understand satellites, we need to talk about Sir Isaac Newton and his brilliant thought experiment.
Oh, okay, Newton.
Newton's cannonball.
The cannonball.
Okay, so imagine you were standing on top of a very high mountain.
Okay, I'm picturing it.
A really high mountain.
Like maybe even reaching into space.
Yeah, like way up there.
Okay.
Okay, and you have a cannon.
A cannon. Okay.
And you fire a cannonball horizontally.
Okay, I'm with you.
Okay, so typically that cannonball would travel a certain distance before gravity pulls it back down to Earth.
Right. It would make like an arc.
An arc, exactly.
Okay.
But what if you could fire that cannonball with enough force? What do you think would happen?
I'm guessing it would go further
It would go further.
before it hits the ground.
That's right. But Newton took it a step further.
And-
He imagined that if you fired that cannonball with enough speed, it could actually start orbiting the Earth.
Wait, are you saying that satellites are like cannonballs
Essentially, yeah.
that were just launched
Wow.
with incredible force
Incredible force.
and are now just perpetually falling around the Earth?
That's exactly right.
No way.
Yes.
So they're constantly falling.
They're constantly falling.
But their forward motion
Yes.
keeps them from crashing down.
It's this perfect balance between gravity and inertia.
Oh my gosh, that is so cool.
It is pretty cool, right?
They're like trapped in this delicate dance between falling and moving forward.
They are. It's a delicate dance.
That is amazing.
But there's a catch.
What's the catch?
The speed needed to actually achieve orbit is way faster than what any real cannon could achieve.
Really?
Yeah, we're talking about a speed of roughly 7,902 meters per second.
That's insane.
It is insane.
And how fast do cannons normally shoot things?
Most cannons only reach speeds of around 1,800 meters per second.
Oh, wow. So it's like way, way faster. Way faster. Yeah.
That's crazy.
Yeah.
It really makes you appreciate the technology
Oh, yeah.
that makes all of this possible.
Absolutely.
That we can actually launch these things into space
Yeah.
and they stay up there.
It's amazing.
It is amazing.
And the source we're looking at mentions some of the really cool things that Singapore's doing with satellite data.
Oh, tell me more.
Okay.
I love hearing about like the practical applications
Yeah.
of all of this.
Absolutely. So what are they doing?
So they're using satellite data to monitor haze
Okay.
and to predict weather patterns.
That's so useful.
It's really useful.
And I'm guessing that without satellites, we wouldn't have things like GPS
Nope,
or accurate weather forecasts.
not at all.
Uh,
Those technologies rely on a network of satellites constantly orbiting the Earth.
so thanks to gravity,
Thanks to gravity.
We have all these amazing technologies.
We do.
That's incredible.
It's incredible, right?
That this one force impacts our lives
Yeah.
in so many ways.
In so many ways.
From like the mundane things we do every day to like
Amazing.
the really like complex and cutting edge technologies.
It's pretty mind-blowing.
It is mind-blowing.
Yeah. But there's more.
There's more.
Tell me.
So you might think of satellites as just kind of randomly flying around up there.
Okay.
But there's actually a lot of careful planning
Okay.
and precise engineering
Yeah.
that goes into their orbits.
Okay.
And in fact, there are different types of satellite orbits,
Different orbit.
each with a specific purpose.
So they're not all just like floating up there?
No, not at all.
Oh my gosh, tell me more.
Okay, so there are geostationary orbits. Geostationary orbits.
A satellite in a geostationary orbit stays above the same point on Earth's surface
As the Earth rotates.
as the Earth rotates.
So it's like the satellite is parked
It's parked.
in space,
Yes.
always looking down
Always looking down
at the same spot.
at the same spot.
Why would they want to do that?
It's super useful for things like communications and weather monitoring.
Okay.
Think about like satellite TV dishes.
Yeah.
They always point in the same direction.
Right.
Because the satellite broadcasting the signal is in a geostationary orbit,
Oh, that makes sense.
always in the same spot in the sky.
But what about like other applications?
Yeah.
Like if you wanted to like map the Earth
Yeah.
or like observe different parts of the Earth,
Right.
wouldn't a geostationary satellite like miss out on a lot?
You're right. A geostationary orbit wouldn't be ideal for that.
Okay.
That's where polar orbits come in.
Polar orbits.
Satellites in polar orbits travel from pole to pole.
Oh.
So they're covering different parts of the Earth with each pass as the Earth rotates beneath them.
So they're like the globetrotters
They're like the globetrotters.
of the satellite world.
Exactly.
Okay, that's really cool.
Yeah.
So I'm guessing they're good for things like tracking like environmental changes
Yeah.
and taking images of the whole Earth
The whole Earth.
and maybe even like spying.
Well, let's just say that some countries do use polar orbiting satellites for intelligence gathering.
Okay. Go.
But you're right. They're great for a wide range of applications, from environmental monitoring, resource management, scientific research,
Wow.
all sorts of things.
It's amazing how
Yeah,
like the type of orbit can
Yeah.
have such a big impact
it does.
on what a satellite can do.
It's like choosing the right tool for the job, right? You wouldn't use a hammer to screw in a light bulb.
Right.
So similarly, you wouldn't use a satellite in geostationary orbit
Yeah,
if you needed to monitor like ice caps in the Arctic.
that makes sense.
Yeah,
It's like gravity is the traffic cop up there, making
Yeah.
sure all the satellites
keeping them in their lanes.
stay in their lanes and
Yeah.
do their jobs.
Exactly.
That's awesome.
It is awesome.
I think we've covered a lot of ground in this deep dive so far.
We have.
We started with like,
Yeah.
the feeling of weight
The feeling of weight.
in our everyday lives.
Yeah.
Exactly.
Then we went to the
The
tides.
tides.
Then we zoomed out to like planetary orbits.
Yeah.
And now we're talking about satellites.
Satellites and their orbits.
It's all thanks to gravity.
It is all thanks to gravity.
This one force
One force.
that we just totally take for granted.
All the time.
Yeah.
Yeah.
But it's responsible for
So much.
so much.
Yeah.
Like the fact that we're even here
The fact that we exist.
on this planet.
It's pretty profound.
It's really profound.
Yeah.
I think we should probably take a quick break.
Yeah, let's take a quick break.
And then we'll come back and talk about even more cool things
More cool things about gravity.
related to gravity.
Stay tuned. Stay tuned.
Thinking about those challenges, one that comes to mind is making sure that the satellite actually reaches and maintains the correct orbit.
Oh, yeah.
It's not as simple as just like launching it up there and hoping for the best.
Right. It's like, I was thinking, it's kind of like trying to throw a dart across the room
Yeah.
and hit a bullseye.
Yeah.
But you're blindfolded
Blindfolded.
and spinning in circles.
Yeah, that's a pretty good analogy.
It's not easy.
There are a lot of precise calculations involved.
Right.
Scientists and engineers have to factor in things like the satellite's velocity, its altitude, the Earth's gravitational pull, even the influence of other celestial bodies to make sure that it stays on course.
So there's a lot more to it than I think I realized.
There is a lot more to it.
What about those environmental hazards that you mentioned?
Mhm.
Like space seems like a pretty rough place
It,
for delicate machinery.
it is very harsh.
Yeah.
Satellites have to contend with extreme temperatures, radiation, Even micrometeoroids. Yeah,
Micrometeoroids.
those are tiny particles
Okay.
whizzing around at incredibly high speeds.
So it's like a cosmic obstacle course up there.
It is a cosmic obstacle course.
They've got to dodge all this stuff.
They do. They have to be very tough.
Yeah, these things have to be like super durable
They do.
to survive all of that.
They do.
And then on top of all that, there's the cost.
The cost?
Launching a satellite into space, I can't imagine that's cheap.
No. It is an incredibly expensive undertaking.
Yeah.
It took a massive investment of resources
To design,
to design,
build,
launch, all of that.
all of that.
Yeah.
So that's why international collaboration is so important in
True.
space exploration, because pooling resources and expertise allows countries to achieve really ambitious goals
Yeah.
that might be impossible to reach alone.
So it's kind of like this global team effort
It is.
to push the boundaries
Push the boundaries of what's possible.
of what's possible in space.
Yeah, it's really cool.
This has been so eye-opening to like all the intricacies of
complexities
Yeah.
of space exploration.
space exploration. I
Yeah.
had no idea.
It's amazing what you can learn
It is.
when you dive into a new topic.
It's really amazing.
It is.
So you talked about the science behind satellite orbits. But I'm curious, what do you think are some of the challenges
Okay.
that scientists and engineers face when actually designing and launching these complex machines into space?
Oh, that's a great question.
Yeah.
I mean, I'm thinking about like all the calculations that have to go into it.
The precision.
To precision. Yeah, to like achieve a stable orbit.
Yeah. And then you have to think about those environmental hazards.
Right. All the stuff they have to avoid.
Extreme temperatures, radiation,
Yeah.
micrometeoroids.
Right? And the costs.
And the cost.
Like how much money it takes to actually do all of this.
It's a huge undertaking.
Yeah, it really speaks to like human ingenuity
It does.
and perseverance
That does.
that we've been able to overcome all of that
Yeah.
and actually like do these amazing things in space.
It is truly remarkable.
It is truly remarkable.
Yeah.
I think that's a perfect place to end this deep dive.
Yeah.
We've explored the amazing power of gravity
Yeah.
from, just the things we experience every day to the complexities of space travel.
Yeah, it's all connected.
And it's all connected. It's
Yeah.
really amazing.
It is pretty amazing.
I think we've given our listeners a lot to think about today.
A lot to think about.
And until next time,
Yes.
keep looking up
Keep looking up.
and keep those brains buzzing.
Keep those brains buzzing. It's incredible to think about all the things they have to get right
Oh, yeah.
to successfully launch a satellite.
Yeah, it's not easy.
Not at all.
But I'm curious, what do you think are some of the biggest challenges that
Yeah.
they face when they're like designing and launching these things?
So one of the biggest challenges is just making sure that the satellite reaches and maintains the correct orbit.
Right, because if it's off by even a little bit,
Exactly.
it's not going to work.
Could be a disaster.
Yeah.
It's not as simple as just launching it up there and hoping for the best.
Right.
There's a lot of precise calculation involved.
Mhm.
Scientists and engineers have to factor in things like the satellite's velocity, its altitude, the Earth's gravitational pull,
Right.
even the influence of other celestial bodies, like the sun and the moon,
Wow.
to make sure that it stays on course.
So it's like a constant balancing act
It is a constant balancing act.
to keep it where it needs to be.
Exactly.
And then on top of all those calculations,
Right.
you have the environmental hazards of space.
Yes, those are a major concern.
Yeah, it's not exactly a friendly environment
No, it's very harsh.
up there.
Satellites have to contend with extreme temperatures,
Okay.
radiation from the sun,
Right.
and even micrometeoroids.
Those tiny little particles.
Tiny little particles whizzing around at super high speeds.
Yeah, so it's like they have to be shielded
Yeah, they have to be very well protected.
against all of that.
They do.
So not only do they have to get the calculations right,
Right.
they have to build these things to withstand like a
Yes.
cosmic beating.
Exactly.
That's intense.
It is.
And then I'm also thinking about like the cost.
The cost of all of this.
Yeah, launching a satellite into space is incredibly expensive.
I can only imagine.
It's a huge undertaking.
Yeah.
It requires massive investment in terms of resources, time, expertise.
Yeah, it's not something you can just do
No.
in your backyard.
Not really.
So that's why it's so impressive
Yeah,
that we've come so far.
it is impressive.
In terms of space
I mean,
exploration.
it really highlights human ingenuity and collaboration.
Yeah, because it's not just like one person or one country.
Right.
It's like a global effort
It's a global effort.
to make all of this happen.
Exactly.
It's pretty inspiring when you think about it, that we
Yeah.
can all come together
Yeah.
and do something as amazing
Yeah.
as launching these incredible machines
It's pretty awesome.
into space.
Yeah.
I think this deep dive has really opened my eyes
I'm glad to hear that.
to all the complexities
Yeah.
of space exploration.
There's a lot to it. Yeah, there's a lot more to it than I ever realized.
More than meets the eye.
Yeah, and it all comes back to this one force.
Gravity.
Gravity that we experience every day.
But we don't really think about it.
Yeah, we take it for granted,
Yeah.
but it's responsible for so much.
So much.
Yeah, from keeping us on the ground
Uh-huh.
to governing the motions of the planets and stars.
It's pretty amazing.
It really is.
Yeah.
I think we've given our listeners a lot to think about today.
I hope so.
Until next time,
Yeah.
keep looking up
Keep looking up.
and keep those brains buzzing.
Keep those brains buzzing.
Keep those brains buzzing.